In this video, I will show you how to perform a binary land cover classification in Python, basically separating vegetation from non-vegetation in your satellite imagery. Hey everyone, welcome back to Remote Sensing Pro. If you're new here, this channel is about making remote sensing and GIS easy and hands-on with practical Python tutorials and real-world examples. Today, we will start by quickly revisiting what we learned in tutorial 4 and 5, calculating NDVI from cropped satellite images. Then we will move on to thresholding the NDVI into a binary land cover map, calculating land cover areas, and finally visualizing the results. Okay, so this is the code for NDVI calculation. I'll start from the first section and go through this code briefly. We have the glob. This is the library we use to import the two bands that we need for NDVI calculation, the first being red, band 4, and the second being near infrared, band 5. And then we have rasterio to read these bands, the first one and the second one. And we also have numpy as NP. So here we calculated the NDVI using the NDVI equation, which is near infrared minus red divided by near infrared plus red. And then we set all the pixels that are 0 to numpy.nan. Alright, finally we used matplotlib to plot the result. Okay, so let's go ahead and run this code. Awesome. Alright, so here you can see that the result here is just the result from the cropped image that we got from our last tutorial. So it's different from the one we calculated before. Initially, we used the large area to do the calculation, but today, since we've already learned how to crop our images, we use the cropped result from the folder here to run this code, and that gives us our study area NDVI. Okay, so now that we have the NDVI result, we can go ahead to have a quick look at the NDVI value range. We can print that with print NDVI. We check the mean. np.non mean, and we have the NDVI. We also do the same for the max. Okay, so we're going to print the minimum value for the NDVI that we have here. And then we'll also print the maximum value. Let's have a look. So here we have the minimum value for this NDVI for our study area as minus 0.317, and our maximum value is 0.6. This we can actually see from this color bar right here, so around this area we have minus 0.3, and here we have the maximum to be 0.613. Okay, now let's turn the NDVI into a binary land cover classification map. Alright, so here we're going to focus on vegetation and non-vegetation. We're going to do this using a single rule. So first we need to select our threshold, and that's why it's important to have a look at the values, or you can just look at the values just by looking at the map. Sometimes you may want to import your NDVI map into remote sensing or GIS platform, and then check the pixel values and the range to help you decide on what threshold you want to use for this classification. I think I will go with 0.2 since our minimum is minus 0.3, maximum is 0.6. And looking at this map, I can see that anything above 0.2 looks more like vegetation, and anything below that threshold shouldn't be vegetation. Alright, so I'm going to select 0.2 as my threshold to distinguish between the vegetation and the non-vegetation. Alright, I'm also curious to know what threshold you're going to use for your own study area, so please share with us in the comment section. Threshold is equal to 0.2. And now we want to get our land cover, so we say land cover. Let's go to non-pi.where. So we need the NDVI. So let me just write the NDVI here. So where the NDVI is greater than the threshold, this threshold here. So 1 should be the vegetation and 0 should be non-vegetation. So this is a binary command. Alright, let's run this code. Awesome. We've got that. And so next is to plot our result. To visualize the map, we'll do that by using plt.figure. And we'll get the fixed size to be fixed size is equal to, I will do 6 by 6. 6 by 6. And next is to show the plot, right? And so I think I will use plt.subplot first of all, since we are doing two plotting this time. So plt.subplot. We'll do the row, the column, and the first one. So the first one is going to be our NDVI, plt.info. Let's get the NDVI, and we'll give it a color, which CMap. Let's maintain this color. We'll do red, yellow, and green. Alright. This will also need a title. Since we are plotting two maps, it's always nice to give the maps title. We'll do plt.title NDVI. And the second one, okay, so the next map beside NDVI is going to be our land cover map, the one we just have here. Okay, let me just bring down everything here. So here we're going to change it to the second map and change NDVI to land cover. And we can't use this color. We want to have a look at the vegetation and non-vegetation. So vegetation is going to be 1 and the rest are going to be 0. So I think greens would do the work better. Then we'll name it land cover map. Okay, now let's show it. We have to do plt.show. And one more thing we might want to do here to avoid the layout issues, we'll do plt.type layout. So let's keep it at type. Okay, something is missing here. We have plt.figure. We have this okay. This okay. This is fine. This is fine, and this is imshow is also fine. And cover map. This is okay. Good. For this land cover, we want to visualize the vegetation and the non-vegetated areas. So the green, as you can see here, are the vegetated areas, whereas anything outside the green color, these ones are not vegetated areas. One other method we can use to visualize our land cover map together with the NDVI is using the animation method, and that takes us to the image animation. So here we have an option to show an interactive map where we have an overlay of both maps, and instead of plotting them separately, we're going to plot them together, and we have an animation that fades vegetation mask over the NDVI. So this is an optional mapping. In that case, I will just paste the code and explain it. Okay, so for this image animation, you just need a couple of libraries. We already know Matplotlib, right? So we're going to import animation from it. You're also going to import RC. And so this renders animation inline in Jupyter. And then for you to plot two maps on top of each other, you need to set the subplot as 1 by 1. Usually we go with the row, the column as 2, and then the image as 1, and then the second one 2. However, for this one, we're going to set the column as 1 instead of 2. Instead of having 1 by 2, that's rows and columns, as 1 row and 2 columns, we're going to have 1 row and 1 column. Next is to show the NDVI. So we're going to maintain the red, yellow, green color for the NDVI. And our mask image is going to be this Landcover image. And here we have alphas, which is going to be the opacity ranging from 0 to 1. And then we have 25 frames. All right, so it's going to just change slowly along the frames. Next is the update. So we define a function here that will return the mask image, which is our Landcover image. And finally, we have the anime. So this anime is going to run the figure for us, which we have here. It's going to run the update. It's also going to run the frames for the alpha, and we have this interval of 100. So for this interval of 100, we just want to run the animation to be between 100 milliseconds per frame. This is what we need for the image animation, and this is going to close the figure so that we don't have extra display outside what we intend to do. I'm going to go ahead to run this code. Okay, the NDVI is the background image, and the Landcover image is what we want to see as we play this animation. Let's have a look at it. Right, and we can also select the loop so we can have more options to visualize what we want and be able to describe what I want to describe right here. Okay, so I want you to watch closely. As you see the background here, we have all of the base soil, the ocean where we have the water, the entire coastal areas. These areas are outside the vegetated selected threshold. All right, you can pause that now. Now let's translate the pixels into real world area. We're going to compute the area covered by vegetation and the non-vegetation and report both hectares. All right, let's have a look. First, we need to get the pixel size from the GeoTransform. So we can just open any band from the same scene to read georeferencing, which includes the transform and the CRS. We'll just do width stereo dot open. Let me open band 4. Let me use band 4 as source. And then transform it. So our transform is going to be source dot transform. From our last tutorial, we learned that this transform is going to help us to map the pixel indices, right, to the map coordinates. So what it does is to map the pixel indices to map coordinates. As simple as that. Next is to compute the pixel areas in square meters. So first we need the shape. So what shape do we need to calculate area? We need the height and we need the width. So the height multiplied by the width, we're going to have the area, right? So we get the pixel width in meters and the pixel height in meters. All right, so let's do pixel width. So let's put M. Unit is very important, just to remind us. And we do ABS transform dot A. Okay, this is our width. So the width of 1 pixel in meters. ABS actually handles negative sign. Alright, so we'll do that for the height, pixel height in meters. It's equal to ABS. We'll also transform it dot E. So here we have the height, the width, and the height. Alright, so we have the shape ready for us. Next is to calculate the area. So to get the pixel area in M2, right, meter squared, because we have height and width. In that case, we're going to now use this width times, I'm going to give it a space, times the height. So that's our area. Okay, now let's do the vegetation pixels. To get the vegetation pixels now, we do numpy dot sum. We're going to sum the land cover equal to 1. This is vegetation for us, right? So when the land cover pixel is equal to 1, then this is going to be our vegetation pixels, right? Next is non-vegetation pixels. So this is going to sum land cover equal to 0, right? Since we are interested in calculating or measuring the class areas in hectares, we have 1 hectare is equal to 10,000 meters square. And since we have our meter square to be in area, so what we need to do is to now divide it by 10,000. So we'll do vegetation area. And so we have to keep the unit one more time to say this is for vegetation area in hectares. This is equal to these vegetation pixels right here times this pixels area. Alright, so what we have here multiplied by what we have here, and that's we're going to divide by 10,000. 1, 2, 3. Alright, we'll just copy and get this here. So this is going to be non-vegetation pixels, right? So we'll just do non-vegetation area in hectares equal to non-vegetation pixels multiplied by the pixel area in meter square divided by 10,000. So now let's print the result. We're going to print. Usually we just do F. Let's give it a name. We just say veg. Just veg is okay. Let me write simple. Vegetation area. We have grab our vegetation area here. Okay, and then we'll close the bracket, and then we do the same for the non-vegetation ones. I'll just write none here. That should be enough. All right, so let's have a look at this. So what this is going to do for us is to print our vegetation area in hectares and print the non-vegetation area in hectares. So this is going to be non-vegetation area in hectares. Alright, so this is going to print our result pretty well. I would like to separate this so that I can manipulate it whenever I need it. So I think everything should work fine. Alright, let's print this. Okay, and now let's print this. We can also control how we show the values by including the decimal places. So I will just add 2 decimal places here. 2 decimal places. And I'll also add the unit in hectares at the back to sort of make it look good. Okay, so we have our 39 and we also have 70 instead of just 7, and then we have the unit hectares right here. Okay, next is to visualize the results in a pie chart. We're going to do that by using PLT as usual, and we do pie. And what do we want to do with the pie? Let me first of all close it and continue. Okay, so I'm going to put everything I need within the pie. The first thing I need is to get the vegetation pixels and the non-vegetation pixels. These are the pixels we want to showcase in a pie chart, right? So I'm going to grab that. Vegetation pixels. We have that, and then the next is the non-vegetation pixels. Okay, we got that. Next, we want to label it. Say labels is equal to, we give it vegetation. And then non-veg. Let's just leave it as just veg, non-veg. Okay. Now we close this and give it a comma. What else do we need? We'll do auto percent. We'll do percent to 1.1. We're going to do that 1 decimal. Then we have the percent. We have comma. Next, you just do the color. Colors could be anything, but for vegetation, I usually want to keep it as green. So I will just do green for vegetation, and for non-vegetation, I could do any color. I could just do white for now. Let me just keep it as white for non-vegetation and green as vegetation. Let's see how it's going to look like first of all. Then if it's not looking good, we can easily change that. Okay, let me bring this up. Yeah, that closes the bracket and run the PLT to show. That's extra 1 right there. Alright. Awesome. Okay, so here we have the vegetation. We have 40%, 40.5% vegetated areas and 59.5% non-vegetated area. Okay, I'm going to change this to gray. Alright, this looks better. We have 40.5% for vegetation and 59.5% for non-vegetation areas. So next, we're going to map different land cover types and we're going to compare the result. So if this helped, please like the video, drop your threshold choice in the comment section like I said earlier, and do not forget to subscribe for more remote sensing and GIS tutorials. See you in the next one.